Hi pre-calc friends, welcome to section 6.2, the unit circle and trigonometry of real numbers. The unit circle is a circle of radius 1 centered at the origin in the xy plane. We use triangles in the unit circle to define trigonometric functions. So if this is a circle of radius 1, then we know the coordinates of this point are 1, 0. The coordinates of this point are 0, 1. The coordinates of this point are negative 1, 0. The coordinates of this point are 0, negative 1. Right, what we're going to be interested in is the coordinates of points around this circle at different points. If we go, I'm going to look at these 4 points right here. I'm going to look at the ones in the middle. We'll go to the others next. So if I look at these 4 points right here, that's a 45-degree angle. So if I use this triangle right here to identify the coordinates of this point right here. So this is the triangle I'm looking at. It's 45 degrees. So if it's 45 degrees, this side has side 1. What's the lengths of those two sides? Because we know, if we know the lengths of those two sides, we'll know the coordinates of that point. Well, let's go back to our triangle. I said our special triangle in the last section. I said if we have a 45 degree triangle, so 45, 45, 90, 45 degrees, 90, which is what we have here. I said you really want to remember this 1, 1, square root of 2 triangle. Now, if I shrink this down, square root of 2 is a little bit bigger than 1. If I shrink that down a little bit smaller, and I look at this triangle, so that is, I'm going to shrink it by a factor of the square root of 2 to force it to be a hypotenuse of 1. If I divide this by square root of 2 over the square root of 2, this is going to be 1 over the square root of 2, and that side would be 1 divided by the square root of 2. So a 45, another 45, 45, 90 triangle has hypotenuse 1, and both of the sides have length 1 over the square root of 2. Right now, also note though, we typically don't leave radicals in the denominator. So 1 over the square root of 2, we rationalize the denominator. Square root of 2 over 2 times the square root, we multiply by the square root of 2 over the square root of 2, and we get the square root of 2 over the square root of 4, which is 2. So if this has, if the length of this hypotenuse is 1, then the length of this side is the square root of 2 over 2. And the length of this side is the square root of 2 over 2. And we know the coordinates of this point, square root of 2 over 2, square root of 2 over 2. If we go, so this is 45 degrees right here, or pi over 4. If I look at this angle right here, and I want to know the coordinates of this point, notice that is just symmetric with respect to the y-axis. So this is going to have, this point's going to have the same coordinates as this point, except the x coordinate's going to be negative. So negative square root of 2 over 2, square root of 2 over 2. And that is for, I'm going to run out of room here quickly. That's going to be 135 degrees. Okay, if I cut the third quadrant right in half, and I look at the points of this coordinates right here, well, that's just symmetric with respect to the x-axis. It's going to have the same coordinates as the other 2 points, although both your x-coordinate and your y-coordinate are negative. So negative square root of 2 over 2, negative square root of 2 over 2. And then if we cut this coordinate in half, we'll identify those angles in a minute. So I got a bump on my table. This point, they're going to have the same coordinates, except the x is positive, and my y-coordinate is negative this time. So it's all our multiples of 40 in one trip around. So if I go around from here to here, that's going to be 225 degrees. And if I go all the way over to here, that's 315 degrees. If I go another 45 degrees, I'm back here, and we're at on the x-axis, and the point is 1, 0. So using this right triangle, I can identify the points that coincide with the unit circle for my multiples of 45 degrees. Once you know one, and remember one, you know the other 3. So we can do the same thing with 30, multiples of 30 and 60. So if we do our multiples of 30 and 60, let's look at my reference triangle for 30. I'm going to do 30, 60, 90. Let's do this. We'll do, this is 30 degrees. That's 60 degrees. Right, and I said we called this side 1, this side 2. This is the square root of 3. Now that's similar to the triangle. Now we want to cut the size of that triangle in half. We want our hypotenuse to only be 1. So here's 30 degrees, 60 degrees. So if we cut it in half, we divide everything by 2. That would be 2 over 2, 1 half, and the square root of 3 over 2. So if we look at this right here, and we look at this 30 degrees, where 30 degrees intersects the unit circle, we look at this triangle. So if the hypotenuse is 1, we must be in this triangle right here. The height is 1 half, and the base is going to be the square root of 3 over 2. So the coordinates of this point right here are square root of 3 over 2, and the y coordinate is 1 half. So for 30 degrees, where the terminal side of 30 degrees intersects the unit circle, so the unit circle, that's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, so 30 degrees intersects the unit circle at the coordinates of the point, square root of 3 over 2 and 1 half. Now just using that fact, and if we mirror this point over here, if this angle is 30 degrees, and that's a mirror image, is going to have coordinates negative 3 square root of 2 and 1 half. And then if we mirror this over the x-axis, this is going to have coordinates negative square root of 3 over 2, negative 1 half. And then this point right here, down here, is going to have coordinates square root of 3 over 2 and negative 1 half. So let's see what our associated angles are. Well, if I go to this angle, right, we're looking at this triangle. So here's my 30-degree angle right here. So that's 30 degrees. This angle from here to here would be, well, it's not quite 180. It's 30 degrees short. So we're going to identify that as 150 degrees. The terminal side of 150 degrees crosses the unit circle at the point negative square root of 3 over 2 and 1 half. If I go all the way around to here, so my initial side's always the positive x-axis. Well, 180 degrees, we go 30 degrees more. This is 210 degrees. And if I travel all the way over here, this is going to be 330 degrees. So our multiples of 30 that are not multiples of 60, we can see where it intersects the unit circle. It's going to be important. All right, so now let's look at this guy right here. This was my 45 degrees. If I look at 60 degrees, all we're doing is turning this guy over, and we're looking at it like this. So the sides of the triangles are the same. We're just switching the adjacent and the opposite. So for 60 degrees right here, so 60 degrees, the coordinates of the point switch. It's 1 half square root of 3 over 2. So if I do the mirror image of that, we know the coordinates of this point, which would be negative 1 half square root of 3 over 2. Because in the second quadrant, the x-coordinate is negative, the y-coordinate is positive. So what angle is this? Well, if this is 60 degrees from here to here, then this must be 60 degrees in here. So this angle must be 120 degrees. And if it's getting really full, don't worry, I have a picture that I'll show you in a minute that's going to be really super handy. Now if we reflect this over the x-axis, we can find the coordinates of these 2 points right here. So if we flip that over, this is going to have coordinates negative 1 half. Both the x and y coordinates are negative in the third quadrant. So x coordinate negative 1 half, y coordinate negative square root of 3 over 2. And down here, we're going to have positive 1 half, negative square root of 3 over 2. So that's 120. If we go all the way around here, well, this angle in here is 60 degrees, so this angle in here is 60 degrees, that angle in there is 60 degrees, and that was 180. So we're at 240 degrees here. And then this is 60 degrees short of 360, so that's going to be 300 degrees. All right, so we put these two pictures together, right? We're going to overlap that one on top of that. It looks like a big mess, But if you go to the last page of this handout, I think it's on the last page of this handout, or in your handout on Blackboard, you'll see that it's all absorbed right here into one nice typed picture for you. So 30 degrees, which is equivalent to pi over 6, intersects the unit circle at the square root of 3 over 2 and 1 over 2. 45 degrees, which is also pi over 4 radians, intersects the unit circle at square root of 2 and square root of 2 over 2 and square root of 2 over 2, so forth and so on. Now I want to say, you really want to know this. You should know where every single one of these angles, all multiples of 30 and 45, intersect the unit circle. And you'll find that all you really need to know is what's going on in the first quadrant. Because once you know what's going on in the first quadrant, everything else just falls into place. All right. So, reference angles, new definition. A reference angle for a given angle is the acute angle, right? What does acute mean? Acute is between 0 degrees and 90 degrees. It's acute, so it's cute, and it's little, so it's little, it's between 0 and 90 degrees. So a reference angle for a given angle is an acute angle that the terminal side of theta makes with the x-axis. Always find the difference between theta and the positive or negative x-axis. All right, so that's a really wordy for what's going on here. So let's say we look at 140 degrees. So if I draw 140 degrees in standard position, this is my angle, 140 degrees. The terminal side is right there. And we always go from the terminal side to the closest x-axis. So we either go to the positive or negative. If we were to go back to the positive x-axis, that's way too far. It has to be less than 90 degrees. So if your angle is in the second or third quadrant, you're going to look at the angle the terminal side makes with the negative x-axis. So if your terminal side is in quadrant 2 or 3, you're always going to look at the angle it makes with the negative x-axis. Now, reference angles are always positive. So if this is 140 degrees, we know that this is 180 degrees. So what is this angle in here? Well, it's 180 short. It's 140. How many more degrees do we have to get to 180? Hopefully you said 40 degrees. Right, so that is, we say 4 theta equals 140 degrees. The reference angle, with a little subscript of r, is 40 degrees. Right, an angle, we draw the terminal side of the angle, we say how far are we away from the closest half of the x-axis. Right, so the reference angle for 140 degrees would be 40 degrees. So that would get us to the negative x-axis.